our story with developing Golang applications. Traditionally, we've been doing a lot of C development in our company, but some time ago we decided we started a new project, and we've been trying to pick up a good technology to do it. And we've been considering many and decided to go with Go. And during this talk, I will tell you a little bit about our experience with Golang, which might be not obvious choice for developing embedded applications, because the stuff we are doing is for the embedded devices. So first of all, I'm gonna mention my very subjective view on Go, but it's also backed up a little bit with experience in the company I'm working for. Traditionally, also I've been doing this talk for C developers that didn't have a lot of experience with Go. So here the audience is very different. Most of the stuff I'm gonna mention today you already know. So for me, starting as a C developer, I think that Go is very productive programming language, and it especially is when you're doing any kind of network programming. And nowadays, most of embedded devices even are network connected, so it excels when you're developing any kind of networking code. And I'm not considering Go to be C replacement, because there are places you cannot really replace C, especially any kind of like device drivers or real-time operating systems. Those are the places pretty much irreplaceable by any other technology. And there are many things I'm going to tell a little bit later about those, but garbage collection is one of those that prevents you from doing any kind of real-time operating stuff. So a little bit about me. My name is Marcin Pasinski. I used to live and work in Krakow some time ago, but since 6 years I'm living and working in Oslo, Norway. And yeah, if you are interested, I will be here to share my experience with the Scandinavian way of working. And we are also opening the office in Krakow right now, so we are looking for Go developers as well. And the two products we are developing in the company are Mender, which is the one written in Go. It's over-the-air updater for Linux devices. It's integrated with Yocto. Who of you know what Yocto is? Okay, no one? That's fine. And the other product we are developing is CF Engine. It's a configuration management tool. And this one is written in C. So we have experience doing both C and Go applications. And very short on the agenda, so I will share our experience with the process of selecting the programming language for the new product. And then I'll tell a little bit about how to do embedded development with Go. I'm having quite a few code samples, and here I'm having a little demo that I'm going to present, so it's written in Go. And starting with our requirements or our story when we've been selecting a technology for a new product. So we divided all the requirements, so to speak, into two buckets. So in the first one, we put everything which was facing our users or customers. So size requirements on the device, embedded devices. People are very constrained with the size of the application because usually they don't have a lot of space on the device. The other requirement was Yocto. So this is kind of like build root or set of scripts for creating images for embedded devices. And then what was super important for us was the possibility to compile our application to multiple platforms. So those were the external requirements, and we've been having quite a few internal ones. So competences in the company, the more people knew the technology, the better. then reusing the code. Our application is client-server. We've been thinking about sharing code between the client and the server. It didn't happen after all, but this was at least the initial idea. Then we've been talking a lot about development speed. Traditionally, we've been doing C. So we didn't want to do C again because it's extremely slow with regards to the development speed. And then we've been discussing common libraries that we knew we'll need, like JSON, SSL, HTTP, and a couple of other delighters, so to speak, like automatic memory management or buffer overflow protection, things like that. And to the final round, we selected 3 technologies, so C, C++, and Go. And we've been doing a lot of POCs and comparisons to see which one will fit best our requirements. So obviously with regards to the size requirements of the device, C was the best one. C++ was a little bit worse, but Go was the worst. Here, then we've been having setup requirements with Yocto. Here C and C++ were supported out of the box, but Go not. And we've been contributing a lot, and right now Go is fully supported by Yocto as well. Then competence in the company. Only one guy at the moment when we started developing our application knew Go. This was a little bit risky for the company to start a project using the technology no one knew at the company. But those were the only 3 kind of disadvantages as we've seen those at the time when we started developing our product. And the rest, you can see we've been super happy with, like buffer overflow protection, code reuse, automatic memory management, access to the standard libraries. And then we've been doing a little bit more testing. We've been testing the mentioned technologies also with some kind of frameworks, like Qt, for example. And then we've been building images for the embedded devices. This table is, I think, quite self-explanatory. So Go didn't do that well at the point when we started. But we've been doing even more tests. And we decided at the end to go with Go. And why we decided so was that Go is having extremely rich standard library. So a lot of the things we've been struggling with using C were there. Then it turned out that the learning curve from C to Go was not very steep, so it was fairly easy to pick up the basics. And then Go is compiled language, so runs natively on embedded devices, which was extremely important for us. And then wide platform coverage, so it was easy to cross-compile for multiple different architectures. And it turned out that it's been similar in size with static C binaries. So usually when you're compiling C binary, then you're having a lot of dynamic linking. But if you do the static C library, it's not that different with size to Go. And we've been thinking that both the client and the backend developer will be able to write the code in the same language. So here, a little bit about size of C and Go. So obviously, when you're here, I'm having probably the smallest in size snippet of code you can do in Go. So I'm not using any libraries, not even format. And when you will compile this hello world thing, then the size is less than 1 megabyte. But when you do some optimization, so when you will strip out the debugging symbols, stuff like that, you can go as low as 623 kilobytes. Now it's even better because I think this was Go 1.5 or 1.6 maybe, but every Go release they are optimizing this a lot. So now I think it will be even smaller. Doing the same with funds package, we ended up with 1.5 megabyte, but runtime of Go is pretty big. That's why it adds up. But when we've been doing the same thing with C, obviously when we've been doing the dynamic linking, then the size of the application was super small. It was 8 kilobytes. But there were a lot of dependencies. And then when you do static compiling, then it's even bigger than Go. And even with stripping some debugging symbols, you're ending up with a static C binary to be bigger than the Go binary, which was pretty nice finding for us, pretty unexpected, I would say. And then we've been obviously considering the performance of the Go application versus C. And here, unfortunately, Go is fully garbage collected. So in most cases, you don't have the influence over when the garbage collector will run. And then Go declaration syntax says nothing about heap versus stack allocation. So you cannot tell where the variable or the memory will be allocated, but you can at least see. So if you do go build minus gcflags minus m, you can see that Go is telling you a lot about which variables are escaping the stack and will be allocated on heap. But from the other hand, we've been seeing super fast compilation, so it's been insanely fast, and probably you've had the same experience with compiling Go applications. Then concurrent execution and communication in Go is extremely nice. It's nothing, or C is much more difficult to do it right. And we've been also discussing the speed of developing the application. So we had some constraints with how fast we need to release the application. So it turned out that in C this was not possible, but with Go we did manage to release it on time. And here very quickly a little bit about compilers and compilation. So I think most of you are familiar with the original Go compiler, which is GC, but there is also GCC Go, which is a front end for GCC. So pretty much you can use GCC to compile Go applications. It's lagging a little bit behind Go version, so usually it's 1 or 2 releases after, so it's not supporting always the latest Go features. But then the compilation, I mentioned that it's super fast, it's single binary, then you have a lot of options for cross-compiling, and you can even use make files if you want to. If you're coming from a C camp, then it's a little bit like old days when you've been doing make files. And here is a cross-compilation matrix. So we are using Linux, and if using Linux, you can pretty much compile for the all possible architectures that Go is supporting, which was pretty important for us as well. And debugging. Also, probably a lot of you know about Delph, which is native Go compiler, but you can use GDB as well. So us traditionally doing a lot of C, we've been able to use the tools we've been familiar with to do some kind of debugging, and GDB was working fairly well as long as you've been not having a lot of concurrency in your applications. With a lot of concurrency, then it's usually pretty cumbersome to do any kind of debugging using GDB. And then a little bit, I'll tell you a little bit about the Go features that we are using a lot and which are helping us to do embedded development. One of those is CGo. So CGo lets you access C code from inside of Go applications, and this was pretty handy because when we are doing a lot of development of embedded applications, then pretty much everything which is very low level which touches device drivers and stuff like that, is C. So Go allows you to use C bindings and run C applications inside of Go code, but this is not for free, so you need to use this C Go enabled, and there is also a performance cost associated with calling C APIs, and this was 150 nanoseconds on the Xeon processor. It might sound not a lot, but when you're having a lot of nested calls to C code inside of loop, then it adds up very quickly. And when you're using CGo, Go is creating some kind of virtual module called C, and then you can just import C and use the stuff the same way you're using any other imported packages in Go, like C3, for example, C string. So there's no difference in calling those C applications from within the Go code. And then it's also possible to use C++ inside Go code. We've been not doing this in the company, but we've been considering this when we've been selecting the technology. You can use Swig. I don't know how many of you have been using Swig before. No one? So this was mostly developed for calling Python and Perl applications, so any kind of interpreted languages, and do some C bindings. So it's not, yeah, we've been not using this, but it's possible, and yeah, there are some code samples you can see here of how to do it. And then Go also supports some kind of like shared libraries, and you can also do Go shared libraries, Go archives, and you can do C shared libraries. So you can build your Go application to be a shared library, and then this is not, we are not using this at the company, but this is also possible. You can organize your application into multiple libraries, and then you can link to your shared library inside your Go application. And this is also possible with mixing C shared libraries and Go shared libraries, so we can create and import pretty much anything. Yeah, and then heap versus stack. So I've been mentioning this already. You don't have the influence over where the variable will be allocated, but you can at least see when the variable escapes to heap. So when you do Go build with the flags mentioned here, when the variable will escape to heap, then you'll see you'll have a hint inside the compiler that this variable escaped to heap. So maybe in some cases you want to redesign or re-implement your application so that it's a little bit more performable when you're getting rid of those escapes. And then the stuff we are using quite a lot is unsafe package. So usually Go is preventing you from creating a nasty stuff, like usually in C, when you want to access some memory or some register and put some stuff inside this register directly. You can use this nice construct with a lot of casting, and Go is giving you this possibility as well. It's inside the unsafe package. So as you can see on this snippet here, this is actually the Raspberry Pi Go library where we are creating or accessing GPIO mem, which is memory mapped access to the hardware, basically, and using some kind of nasty casting, you can actually access this memory directly. it's not, it doesn't look nice, but it does the job. And here at the end, our experience with Go so far. So especially when we started, we've been having a lot of issues with vendoring third-party dependencies and libraries. So there are a lot of different ways you can, you could and still can actually use to vendor the libraries. There are ways to, or work started to standardize this, but it's still a little bit messy. Then community libraries varies a lot. It's not Go specific, it's usually most of the languages and libraries you are using, but the thing is, Go is pretty new language, and there's a lot of libraries that are not having 20,000 GitHub stars, for example, or stuff like that. So you need to be a little bit more careful and experiment with the stuff which you don't know a lot about the quality. And then I mentioned already Yocto. So this wasn't supported, but we contributed a lot to make sure it happens. And CGO, our experience was that it's pretty cool that you can use C bindings inside of Go code. But when you're doing this, then all the easiness of cross-compiling is gone. So there's a lot of issues with using CGO, especially when you're compiling for the embedded devices. But on the bright side, it's been very easy to do the transition from C or Python. So when you do, and when you know Python or C, it's fairly easy to learn Go. Then extremely nice tooling and standard library. And we did some exchange of the task between backend and the client team, but not as much as we would like to see. And then I really do think that Go is super productive programming language, so it lets us do the stuff a couple times faster compared to C. And the last one is pretty questionable, I would say. So a lot of my friends disagree with this statement, but first coding standard is also something I personally really like, because no matter what library you're looking at, the code always looks the same. So it's really nice and it's really easy to read anyone else's libraries. And at the end, yeah, now I'm having a little bit different demo. So at the end, I'm gonna present you some application that's written in Go. So this is Raspberry Pi car, and it's running Go application inside, and it's having a very simple React front end. So I will try to connect there and see if it's working. Okay, so it's a very simple application. It's React, and here I'm having two joysticks. One is to move the car, and the other one is to move the camera. So I hope it's gonna work. Right. So yeah, it's written in Go. It's I'm using some third-party libraries. It's called GoRobot. Pretty handy when you're doing some kind of embedded development. But I've been also playing a little bit with some C standard or C libraries and C binding. So yeah, this is a proof that you can actually use the Go codes to run some kind of embedded devices. Thank you. Okay, any questions?
So this question must be asked, why not Rust?
Actually, we've been talking about Rust as well, and yeah, the thing was that Go, at least one guy knew in the company, and Rust, yeah, we've been not having a lot of experience, and Rust is probably a great choice for embedded devices or embedded applications, but I'm not sure if it's the best choice for doing the backend applications. And as I mentioned, one of the requirements we've been having was that reusing or sharing the code between the backend and client would be handy and nice. It didn't happen after all, but this was at least the thing we've been thinking of when we've been selecting the technology.
So will the Go stay in the company for future development?
Yeah, I think so. So it also depends on the technology. So the question was if Go will stay in our company. I don't think you should, fix all the problems using the hammer. So probably depending on our needs, we'll either do Go again or we'll do something else. So we are considering Rust actually for one of the application we are building at the moment, but for sure when we'll do some kind of backend networking and stuff like that, then Go will be probably top of the list to be selected as the technology for doing this future application.
Just one question out of curiosity, because CGO is natively supported by Go. What about the suite? Is like a third-party thing?
It's third party.
Is it possible to build something like that without CGO, only pure Go?
Yes, but you'll need to spend some time doing this. So with Raspberry Pi, it's a little bit sorry, it's a little bit easier because the community and developers, they made a lot of really amazing work to make it easier for people to develop the application. So for example, a lot of access to GPIO